Alright, got video number 2 here, and this one gets a little more in-depth to actual squaring up the machine itself. Alright, let's continue. I am not a big fan of these things. I see the newer models aren't using them like this. This is a coupler. There are holes in it that couple the threaded rod onto the motor itself. My problem with this is when you use these, things are solid. So that means that your shaft is pretty solidly connected to that motor. What happens in that case is it's possible that the shaft, as it's running around and around, might move a little bit and it'll override these guide rods. We don't want that to happen. So generally they put like what they call a Lovejoy in here. Sometimes they're called a few different things. Like I say, I see the newer connectors, they got a spiral Lovejoy on them, so that's nice, but I didn't get that model. So what I did was I took some hose and made it similar to my older ones, so that I've got a little bit of flexibility where that comes together and the shaft can guide what's going on. Now let's get down into the nitty-gritty of what we're going to do here. This is what we're going to use to measure some of the straightness with. It's a height gauge. It's a older, kind of cheapy one. It'll get the job done. It's not perfect by any means, and that's what we're going to check right here, right now, is how far it's out, and it does lean a little bit. So what we've done here is we got that set on 0. That's the height gauge. We got some other numbers over here. We got this indicator. We got that set on 0 on the big needle. And this little needle over here, this is for how many revolutions the big needle made. Okay, so we made 1 revolution on the big needle, and we're back around to 0. It's about a turn and a quarter, actually. This surface plate right here, this one's mine, one I made. I checked it 1,000 times. I know this is incredibly square. We're going to check it over a distance of 3 inches to see how far the height gauge is out. Last time I checked my angle plate, I think it was out 1/10 maybe over its total length. So it's really close. So let's raise this thing up 3 inches, and we're going to go exactly 3 inches and see where we end up. Revolutions 100 thousandths. Okay, here's 3 inches. So now if we look, we can see that thing has moved about 4 thousandths. If I pull this back, and that tells us that that they got farther apart. Had they gotten closer together, the needle would have went this way. So they got farther apart from each other. So that tells me that the height gauge is leaning backwards. The top of it is leaning away from the angle plate. So this is the angle that we know that this height gauge is on now. Over the course of 3 inches, it's about 4 thousandths. Thickness of a piece of paper. We could even check that really quick. And we're pretty close to back to 0. So we know that that thing's leaning out. Okay. What we're going to do now is, here's our printer, but what we're going to do now is check the rods that the Z-axis travels on, the up and down. There's one, there's the other one. We're going to check it with the height gauge. We know that we're out 4 thousandths for every 3 inches, and we know we're leaning back. I wrote on the top of it, put a little arrow on it, okay? We know that's the problem with our height gauge. So, we got her set up down here, and got her on 0. That's on 0. The little dial is again, we've made 1 revolution on the big dial, so that's on the 1. I notice I haven't zeroed that out, but I'll do that. I'm going to zero this out. I like them to be in a nice spot, so we're going to just take it up to 0. Okay, we got that all zeroed out. And now we're going to run up 6 inches. So we know that over 3 inches we're 4 thousandths out, so it's safe to assume, and anytime I use the word assume, we're throwing another variable in. We're multiplying our problem. Okay, we're going to assume that over 6 inches, it's out 8 thousandths. So let's jump up 6 inches. There's our 6 inches. And see where we are. This says we're on about 11. Now, which way is that 11 leaning? If I pull back on this, it goes the other way. So that means it's leaning away from us 11 thousandths. And we know that the height gauge is leaning away from it 8 thousandths. So we got to add them together. So we're looking at 19 thousandths over 6 inches. We like to check that twice. Make sure nothing moved on us. Go back down to our original 0. And just in case anybody was wondering, the tip down here that I'm using on this indicator, it's flat here on the end of it. This surface is flat, so that if that rod is leaning forward and backward, we still got a flat surface to ride on. Okay, let's get down to 0. Always want to go down last, be the last move you make. And let's see where we're at. Well, something moved. Let me make sure I'm all the way down. No, something definitely moved. Yeah, it looks like we got about 12 this time. Yeah. I'd say we're still on 0, within a needle of it. Let's go back up. Solid 12. Back on 0. So I feel pretty comfortable saying that our indicator shows 12. We know our height gauge is out 8, 20 thousandths over a 6-inch span. I'd feel pretty comfortable with that number, saying that. What's 20 thousandths? Well, a piece of paper is 4, so it's 5 pieces of paper. That's how far we're leaning in. That was side to side. Now we're going to check her front to back. I got her zeroed out here. We got 0 on the big needle. We are on the 1 on the little needle for 1 revolution. We're all zeroed out. Now let's take her up and see what we got. Wow. we're at 0. And one would think that that is good, but really it's not, because we know that over the course of 3 inches, we're leaning back 4. So we've traveled 6 inches. That means we're leaning back 8. So we know that rod is leaning towards us by 8 thousandths. Make all of our double checks. Sure are. And let's go back up one. Maybe a half below 0. We're going to call that good. So we know that rod leans 21 way and 8 towards us. Put that on a little chart down here. Keeping track of which way everything's leaning there. Okay, let's set up on the next one. Got ourselves zeroed out on the left upright, bar, Z-axis, whatever you want to call it. Let's jump up and see how bad this one is. Wow, another bad one. Let's call that 18. Do a little quick double checking. And not just 18, but it's leaning 18 close to us. It's too close to us by 18. Needs to be farther away to get to 0. So actually it's leaning in the same direction that our height gauge is leaning. Still on 0. Whoops. Whoops. And we still got 18. But this time we get to subtract, because we are in fact leaning the same way that the, am I thinking right? Yes, that is leaning towards us. That's leaning away from us. So we get to subtract. And that one's leaning towards us about 10 thousandths. Which is pretty close with the other one, which is leaning towards us 8 thousandths. Alright, set up on that last one. And here we are, last but not least, we're on the left-hand rod on the right to left, seeing how far we're leaning right to left. Boy, this one is tight, getting everything in there with that motor. That motor hangs out so far it wants to interfere with everything. But we got her in. We're barely sitting on the rod, but she's there. We're zeroed out. We're on our 1 on the small dial. Let's take her. I have to have a mirror to be able to see where my 6 inches is. Looks like we're at 2. Well, we're going to call that 0. Let's run back up, make sure we still got. I'm going to say we're still on 2. So, we now know what direction all those are leaning. On to the next step. We don't have a lot of control over those Z rods. I mean, if I'd have been more careful when I was putting it together maybe and not glued things so soon, I might have been able to jimmy some of that out, but it's a 3D printer. We're not building watch parts here, so we're not going to worry about it. This, though, is something that is easily thrown out and can readily be adjusted. So here we go. You take these two Z rods right here, and you make a straight line through them, hypothetically, theoretically, whatever you want to call it. So we got that straight line running through there, and what we want to know is, are these two rods 90 degrees? So in other words, do we have a nice 90-degree angle here and here in relationship to those? That's what we're checking next. First thing we got to know is, how far away is this rod from this rod? I've measured these a bunch of times, got some decent numbers. This is how we did her. And we got 5 inches 332. Just like everything, we're going to check her more than once. $319. I don't like that at all. $327. $329. So what I did earlier was I checked this a whole bunch of times. So on here, on our little diagram that I drawn, that's this dimension right here. So we're going to use 5 inches 329. We just took a rough estimate with a scale, actually a pretty accurate estimate, of how far down we were, and we're looking at 7 inches there. So on this leg, we're going to run that at 7 inches. And then with a little a squared plus b squared equals c squared, we come out with a hypotenuse of 8 inches, 798 thousandths. So we know that if we were to measure from here to here, if that's a perfect 90, we'll have 8 inches, 798 thousandths. I don't have a way to measure that. So the reason we do this is for a comparison. On this other side, I measured it all up earlier, and what we got on it for a length was 5 inches, 361. So in other words, this distance and this distance are not the same. Otherwise, if they were the same, I could just make these distances the same and everything would be square, but they're not. We're using 7 inches, and then the hypotenuse, or the angle across there, comes out at 8 inches, 817. What that tells us is that we need this side to be longer than this side. By how much? Roughly 20 thousandths. The bottom line is, this side's got to be longer than this side, and that'll put us close. We're shooting for 15 thousandths. The way I was checking that, we've got this little setup here. Got the indicator on the end of it, so we can read what's going on. We got a V block. This is precision ground. This V right here is real nice and smooth and perfect 90 in there. So we can set this on here. We can pull up till we feel it stop very, very carefully. You can bump across here and get a reading. Let's call that 10. 10 or 11. Then we could check this side. Move things over here. Feel Little reach. And we can check this side. And as you can see, we're at about 5 or 6 on the other side of 0. So we know, because of that, we got 6, we got 5, it's about 21. We know that this side is 21 thousandths longer than that side. I'm going to leave that alone. I'm not going to mess with that. But I did have to mess with it, and the way I adjusted that is, if you take a look here, you got these threaded rods. I can loosen these nuts up and move this piece towards us, making this side longer, and it'll push everything that way. Or I can back that nut up, make this side on the threaded rod shorter, and it'll suck everything back in the other direction. So I actually bounced this back and forth until I got it where it is right now. Earlier I was checking it, I was seeing myself at about 16, getting about 20 now. That's within a sheet of paper. That's pretty close. So now we know that we're going to assume, we don't know, we're going to assume that we've got a 90-degree angle here. And we're definitely within a half a degree. I would venture to say we're within a quarter of a degree of that 90 degrees. What that does is keeps your print from walking off sideways. Okay. On to the next. I realize I did miss something. I had checked this, but just to show you guys, the y-axis bars here, we want to make sure that they're parallel with the table itself, because a lot of our checking things, like the how straight up and down the Z-rods are, depends on these being parallel with the table. So just as a quick check on that, we're going to zero out on this one. Okay, I see that one's 0. And as you watch the needle, it goes right up to 0, so there's no extra turn in there. Let's come over here and check the left one. And we got about 1.5 there to the short side, what we would call the minus side. So that's minus 1.5. Okay. Okay, once we get in on that one, we're going to call that, well, the camera's got a funny angle on it. 2.5, no, she's 2.5 to the plus side. And we're going to call that a minus 2.5. So, just to make sure 0 didn't get moved, let's go back to the first one. Make sure we're still on 0. We're off a little bit, off by a thou, not bad. We're going to call that pretty darn close. We're within a sheet of paper. What we're going to do now is level this table. Man, this is the one that'll get you in a lot of trouble. People don't get that bed level, and it creates all kinds of printing problems for you. So this is one of the more important ones, really. We'll be setting our Z this way to make sure that it's parallel with the table, and then we'll set the plate to that. And the whole deal is, let's say you're making this one that we did from here to here and from here to here is pretty important too, because that keeps you from making a trapezoid, you know, like say you're making a rectangle like this box right here. If that, do you want to make a rectangle or do you want to make a trapezoid? That's what this one here is all about. Rectangle or trapezoid. Now what we're setting right now is a Z, and this kind of the same thing comes into play. As that thing climbs up, do you want a rectangle or do you want a trapezoid? Meaning, you know, your rectangle will be leaning. So that's what most of this squaring up is all about. So first thing we're going to do, let me get you moved over here so we can see these indicators. And these are the indicators we're running. We got the more coarse one of the two right here. Just for reference, that 0 to 15 is, well, if that was 16, you know, so if we went one pass of 15, that'd be 4 sheets of paper. So half a revolution on that one is roughly 4 sheets of paper. This other one here is the ridiculous indicator, where a half a revolution is 1 sheet of paper. Okay. Well, first we gotta see where we're at. We want to make our Z square with the table. So the one on that is 1/1000th of an inch. Now let's hop over here. We got our 1 revolution and about a half of a thousandth. So take a sheet of paper, divide it into 4, and we're half of one of those. It is the difference in the height in these two. Man, that's plenty close enough. So now we're going to go down here, and this one I'm going to kind of leave it big, so you're going to have trouble seeing the indicator itself. But now what we want is to see where we're at here. I've already played with this quite a bit. This thing is miserable. I hate leveling beds. It's my nemesis. But if we go over here to this corner, that's about one the positive side. I know which way this needle's spinning. So that makes it get higher up. So we're 1 to the white side. There's a little black line in here that's got the white side and the black side. So as we come over here, and get that out of the way, we're 1 on the other side, so total of 2. Now we're going to speed on up here, and we're back 1 to the other side. And that's on 0. So I'm going to call that good enough. I want to show you here. And if any of them weren't on 0, we can turn these wing nuts right here and move it. Bounce it around a little bit, make sure it comes back to 0. And just for that final check, let's wing down here. You can see there is some deflection in the glass a little bit when you're measuring like this kind of accuracy. And across. There we go. A bit of dip there in the end. And we look pretty good. So, just for the fun of it, let's go out here to the middle. And it's pretty close to 0. So now, you know, just because we like to be safe, let's make sure we're still on 0 on these. Nothing moved. Nothing changed. And we're reading a couple tenths the other direction. That just could be we know that our granite or our slate isn't perfect. And there's about a half there. So, that's what that's all about. And we're going to call that good. And that little box there I made, baby needed a box for light bright pegs. One she had got broke. I just made a cheapy one the first time, so we made her a little better one, but that worked good as an example on why we're squaring that up. Okay. Well, we finished up the printer and we made a print. Made a couple prints actually. She ran pretty good on the first trip. Printed a cube. We'll give you a quick little look at that. There's the setup. Not quite finished yet. Got to get all my ducks in a row there for the filament and whatnot. Okay, there we go. Here's the cubes. Fire up the old calipers. This is a 20 millimeter cube. And we got 20.1, that's in the Y direction. We got 20.2, it's in the X direction. That's 20.1 if you get it down off that top. And top to bottom, she's 20.5. We'll probably make some adjustment on that. And that stepper motor for that. But that's how she came out. And the squaring up really doesn't have a lot to do with them dimensions. A little bit, but not much. There's the benchy we made. Wasn't perfect. Popped loose from the plate on me, but not too bad. Alright, so that's how you square up one of these Anet A8s. And, alrighty then. Oh, and by the way, let me see you do that with one of them Ender 3s.